Good morning, everyone. My name is Clayton Jones from Teledyne Web Research, and today we're going to go over Slocum Gliders, mammal mitigation, and the applications of the vehicles. So I thought I'd start out with the mammal mitigation portion of it. As people know, and it's pretty well known, many species are considered vulnerable today, critically endangered. We're down to about 400 North Atlantic right whales. And the factors that have contributed to this population decrease: pollution, climate change, aquatic construction, overfishing, boating and ship strikes, and noise pollution. So while whaling is banned in many countries, we're still kind of in a very dangerous and critical area to lose an entire species of mammals. So the affected industries for this: oil and gas, offshore construction, the military, maritime transportation, and of this, and renewable energy for soundscape. Of this, the critical things that we'll talk about today are ship strikes, noise pollution, subsea tool use, which is also noise pollution, technology testing, and then the traditional method for these industries to mitigate the risk of striking or affecting this population of species is to use human inspection. That is, you have a watchstander on a ship, often, unreliable, you miss that, weather, etc., and aerial surveys, which are costly and also are affected by weather and getting up. So one of the solutions that we've provided here are the Slocum Glider. So the gliders are relatively quiet in their transportation. They're using buoyancy to go up and down. So the only time the motor is running is down at the bottom inflection, where it pump out some oil to change the volume of the vehicle, changing its density so that it's positive and it flies upward. When you sink, you pull the oil back in, it flies downward. So you're flying this undulation path in the water column. Presently, we offer two passive acoustic monitoring options, and those are both the Hui Dmon sensor, we'll take a look at that, and the Jasco Ocean Observer. So as the sensors detect and process acoustic events on board in real time, the data is analyzed, distributed to users, and this long-term monitoring over great distances is available to us because the gliders have endurances of over a year. So we've taken some of these gliders and crossed the Atlantic Ocean, come back down, crossed again, available to not only that endurance and time in the water and the distances, but we'll see with weather situations, hurricanes, nor'easters, they're available all the time. So they're not affected by that weather pattern. They're affordable. The vehicles are saving money compared to vessel or aerial surveys, and the reliability is just 24/7 monitoring in any sea states. So we'll speak first to the Hui Dmon. This is the digital acoustic monitoring system developed by Mark Baumgartner and Hui to detect, classify, and report mammal calls. So specifically, they have right whale detection set up. They have other frequencies and for different species, but that's what they're really focusing on now. This passively monitors for marine mammal sounds. They identify the species based on the characteristics of the sound. That's transmitted via satellite back to shore in near real time. It's mounted externally. You can see it on the front of the glider there. It's a fared acoustically transparent polyurethane, so flow noise is negligible. And this integration has gone on since 2015. And you can see here in the upper right, with Woods Hole Oceanographic, the gliders in their tracking for the ocean tracking network, and the red symbols there indicate the hits that they've had. So really have a good track record of operating these systems. They've been very successful. The other group that we've been working with is Jasco, and Chris is here to answer any questions if you'd like. The detectors are used not just for mammal mitigation, but for multiple applications: ambient noise, ASW, anti-submarine warfare. We've got multiple hydrophone options. Top of the glider, we can add some separation here with the wings, the top, and a forward section. Once again, the onboard acoustic processing is taking place in the Jasco Observer, and the data recording and then data offload comes through the same satellite system, and so you get near real-time detection of these mammals. The power is about 3.5 watts, so it's very low power, once again contributing to our endurance. So here's a case study for maritime transportation, and you can see up there in the red, there's a lot of maritime transportation. So by using a combination of slowing speed or rerouting the ships based on the mammal mitigation data, it's a significant savings for the shipping companies. So if you blindly just slow down a ship in an area of mammal activity, you've got a 1 to 2% increase in cost for shipping companies. However, if you reroute based on this mammal mitigation data, you decrease your cost by over 3%. If you do a combination of rerouting and slowing the ships, it's a decrease of cost of 1 to 2%. Now, those percentages don't sound very high until you look at the costs associated with the shipping. So there are some really significant value of dollars saved here, and really in an effort to avoid ship strikes. So legal ramifications, just the right thing to do. Here's a case study of building this whole information set, this data. So we've got mammal mitigation, we're doing acoustic detection and recording, near real-time reporting on that. But if we track the whale habitat while listening for whales, it gives you even greater advantage and leverage as to where these mammals are going, okay? Here we've got NOAA. So NOAA has lost their ship time down in Antarctica, but they're still required to make measurements here. So these are glider tracks instead of ship time. And what we're doing is replacing trawl nets with an AZFP, that's an acoustic echo sounder there, and we're finding these same pockets of krill. So we have individual fish, pockets of krill, zooplankton, and we can now look at the feeding habitat for these whales in addition to listening for them at the same time. So trying to put together this whole solution package on a platform. By building on that, the other gliders are being used now. We call them storm gliders. So while our hurricane track prediction has bettered over the last 20 years, our storm intensity prediction still remains pretty poor. By having even a single glider in front of a hurricane and trapped in a hurricane, we can reduce those error bars significantly. So really the difference is, should you evacuate someplace, or you're going to flood the New York subway? So this all pulls together into storm glider, environmental monitoring, climate monitoring, and at the same time, while you're doing that, you can be listening for whales. So it's just an extension of the capability of the vehicles. And here you can see coastal upwelling. This feeds into the food production for the mammals, but it also allows us to determine whether, as a storm comes through, we're going to push a wall of water up to the shelf, or we're going to allow it to dissipate. So lots of combined effort here in the modeling sets by tracking weather, climate, characteristics of the ocean, and at the same time listening for whales. Building on that same solution, the gliders can carry acoustic modems. So if you have an undersea network and you need a data telemetry system or a data mule, we call that a gateway glider. The glider can collect information from bottom nodes acoustically with the modems, come up and surface and relay that information. Or if the conditions are right, the glider can sit right at the surface and be a direct conduit down through to those. So really building a networked infrastructure. We've got climatology, storms, weather patterns, acoustic nodes, maybe doing fish tracking at the bottom, using the vehicle to track biomass, and kind of putting together this whole model and picture of the vehicle and enabling us to better understand what's going on into the world's oceans. So a little pitch that we provide at Web Research, complete solutions. There's an experienced glider piloting, 24/7 support, service plans, training center, field support, data hosting. So really putting that whole package together and making it easy for people to use. Does anybody have any questions? I'd like to thank you for your time this morning. And here I'll just leave up who to contact in our team. And I'd like to thank everybody for attending.
Teledyne Marine. Everywhere you look.